Jai Shri Ram to everyone. Now we are going to see one of the very important experiment, that is hardness test using EDTA titrometric method. The learning objective is to understand the causes of the hardness, methodology to determine the hardness, what is the difference between temporary hardness and permanent hardness, then compare with the relevant standards. The main experiment procedure to determine the total hardness, carbonate hardness, non-carbonate hardness of the water sample. So we require standard EDTA solution, that is 0.01 molar ethylene diamine tetraacetic acid, then ammonia buffer, erichrome black tea. This is for the total hardness as well as temporary hardness. Next, we will see the concept of hardness. What is hardness? Originally, hardness of the water is measure of soap consuming capacity to produce the foam or the lather. And it also produces scale in hot water pipes, heaters, boilers and other units, right? Because of presence of very important calcium and magnesium ions, which is commonly present in the water. When the water is precipitated out, these ions are precipitated out because of the polyvalent metals such as aluminium, iron, magnesium, thorium, zinc and other hydrogen ions. Generally, calcium and magnesium are usually present in the water. So hardness of the water is considered considerably it will vary from place to place. Surface water as well as groundwater will both have the hardness sometimes because of dissolved salts of carbonates, bicarbonates, chloride, sulfates, nitrates of calcium and magnesium. Next we will see what is temporary hardness and what is permanent hardness. So temporary hardness is mainly due to the carbonates and bicarbonates of calcium and magnesium. Then permanent hardness is mainly due to the sulfates and chlorides. So the temporary hardness plus permanent hardness is equal to total hardness. So how to remove the temporary hardness? Very simple. I can boil the water and I can remove the temporary hardness, or I can use the excess lime I will add the excess lime so that the temporary hardness is removed. But to remove the permanent hardness, we require chemical treatment such as lime soda process, zeolite process or ionization process, etc. to remove the hardness, permanent hardness. Right. So here, first I will find out the total hardness, then the same sample is boiled and cooled. Once again I will find out the hardness, because when boiling is taken place, the temporary hardness is removed, which is remaining only permanent hardness. So I have the total hardness, I have the permanent hardness. So how to find out the temporary hardness? Total hardness minus permanent hardness will give the temporary hardness, right? So here the hardness is once again expressed in terms of milligram per liter of CaCO3, right? So to find out that, I will use EDTA or sodium salt soluble complex when it is added with a metallic solution of certain metallic cation. So in that case, when we add the erichrome black tea to the hard water containing calcium and magnesium, the solution will become wine red. Then you titrate it with EDTA. So the calcium and magnesium complex are sufficient to EDTA. Of EDTA has been added. So the wine red turns it into blue. That is the end point. So at the titration, generally the pH is maintained. The value is maintained as 10.2. For that I will add the ammonia buffer. So buffer solution is added before the indicator is added, right? So for the regular public consumption, the hardness of the water should be between around 75 to 115 milligram per liter, right? So what is the classifications of hardness? If the water is said to be soft, then the hardness should be less than 50. Moderately soft means the hardness should be between 50 to 100. Slightly hard means 100 to 150. Moderately hard means 150 to 200. Hard water means between 200 to 300. And very hard means it is above 300. So what is the procedure? First, I will find out the total hardness. So around 25 ml of sample I have to pipette in a conical flask. Then I will add ammonia buffer solution. Once again, why ammonia buffer is added? To maintain the pH around 10. Afterwards, pinch of erichrome black tea indicator is added. So what happens? The color of the solution turns it into wine red. Then in the burette, I will take standard EDTA solution. So that conical flask, the sample is titrated with EDTA solution until the wine red color turns it into blue. Now note down the reading, that is V1, initial and final reading. So V1 is equal, 3 trials I have to do. V1 is the average of that. Initial reading and final reading is taken using the burette. Then the titration value is final reading minus initial reading, 3 trials. Average of that I will get V1. Next, I will repeat the procedure, but the sample for the permanent hardness is, so around 150 to 100 ml of sample I have to boil it. Then using the heater, then I have to cool it to the lab temperature. Afterwards, once again the same procedure what I have done, that is 25 ml of sample I have to take, then add the ammonia buffer, erichrome black tea EBT indicator, color turns it into wine red, then titrate it with EDTA solution until it becomes blue. Once again, initial reading and final reading in the titration I have to take 3 trials. Then the average of that is taken as V2. V2. So whatever the value I will get, that is permanent hardness. Temporary hardness is because of, once again I told, because of carbonates and bicarbonates of calcium and magnesium. That is goes off or removed when I will boil it. Right. So the next we will see the procedure in the titration procedure. Afterwards I will show the calculation part. Next, in the next part, we will see how to find out the calcium and magnesium in the hardness. First, I have to go for the total hardness, whatever the procedure we have repeated. But the chemicals required for calcium and magnesium hardness is once again EDTA solution, but now the indicator is changed, that is Moroxide indicator, and the buffer solution I will take standard sodium hydroxide solution, that is 2 normal. What is calcium and magnesium? That is a major constituents. It is in maybe in the presence of carbonates, bicarbonates, chloride, nitrate, etc. So I have to find out. For the drinking water, the desirable limits of total hardness should be less than 300. Permissible limit is less than 600. Calcium hardness should be less than 75. Permissible limit is it should be less than 200. Magnesium hardness should be less than 30. And permissible limit is it should be less than 100. So what is the procedure for this? First I have to find out the total hardness, right? So for the calcium analysis, I have to take 25 ml of sample, raw sample, then I have to add 1 ml of NaOH solution, that is 2 normal sodium hydroxide solution, to maintain the pH. Last time for the total hardness it should be less than, the pH is maintained for 10 or 10.2, here I have to maintain 12, right? Therefore 2 normal solution is added. Then I will add Moroxide as an indicator. Once again the salt, the color will change to pink. Then titrate it with EDTA solution till the color changes to purple. pink to purple. Note down the value. Now it is V3. Right, average of that. Initial and final burette reading, 3 trials. Note down the value. That is V3. Right. So these are the laboratory procedure what we have to do. Next we will see the laboratory procedure. The name of the experiment is to determine the temporary hardness, permanent hardness, total hardness, calcium and magnesium hardness of water sample. Now we will see what are the chemicals required. For the temporary and permanent hardness, we require 0.01 molar EDTA, then ammonia buffer, erichrome black tea as an indicator. Then for the calcium and magnesium hardness, EDTA solution is required. Then we require 2 normal NaOH. Indicator we are going to use, it is a Mur oxide. The chemical contents we have seen. Now what are the other accessories we require? We require conical flask, burette, funnel. We require funnel. Then we require heater. We require beaker. Then we require pipette. So these are the total setup which are required. First, I will find out the total hardness of the water. Total hardness of the water is determined, which include temporary hardness as well as permanent hardness. So now I have taken a raw water sample. In this water sample, both temporary as well as permanent hardness are present. So together we call it as total hardness. Once again, now I will take 25 ml of water sample using a pipette. Then I will add 2 to 3 drops of ammonia buffer. This ammonia buffer will stabilize the pH. So once I add the ammonia buffer, I will stir it. Right. Now we have to add the indicator. The indicator which is used here is erichrome black tea. It is a salt. So I am adding erichrome black tea or EDTA. Sorry, EBT. Now you can see the color. Now the color is wine red color. Right. In this burette, I have taken 0.01 molar EDTA, ethylene diamine tetraacetic acid. Right. So once I have prepared the chemicals, added the indicator, now I have to titrate until the color changes to blue. So slowly I have to titrate. Now the color changed to blue. So this was the initial color. This is the final color. Initial color as well as final color. Before starting the experiment, what I have to do? I have to note down the initial reading. I have taken it as 0. Now what is the reading? What I have to note down? Right. So I have to take down final reading minus initial reading. Afterwards, I have to note down what is the total amount of EDTA which is consumed in this experiment or in this trial. Similarly, I have to do 3 trials. Then you have to substitute in the formula, you will get the total hardness, which includes permanent hardness as well as temporary hardness. Now, in a beaker, I have to take around 150 ml of sample. The same sample which I have used for the titration. Right. I have to boil this in a heater or any other parameter or the equipments you have until it reaches the boiling point. After it reaches boiling point or if water boils, then allow it to cool. Then once again I have to repeat the same procedure. So what I will do? I will take 25 ml of sample. Now I have once again boiled and cooled sample. I will take 25 ml of sample. Then I will add ammonia buffer. I will stir it once again. I will take EBT. Same procedure. Initial color, you have to note down. Then you have to go for the titration. One thing you should be very, very careful. Now the end point is the amount of EDTA consumed will be less because the permanent hardness will be there. Temporary hardness will be removed from the water when you are boiling it. So whatever the volume it is consumed, so if initial is V1 for the first set, second set for the boiled and cooled water sample, it will be V2. Similarly, you have to do the 3 trials, get the average of V2. That if you substitute in the formula, you will get the permanent hardness. Now how to find out the temporary hardness? You have the total hardness and you have the permanent hardness. Total hardness minus permanent hardness will be the temporary hardness. So this is about temporary hardness, permanent hardness and total hardness. Next, I will going to show you how to conduct the calcium and magnesium. So for the calcium and magnesium, initial setup I will do the same, that is total hardness you should know. For the total hardness, you have to take sample, you have to add sodium, ammonia buffer, then EBT, wine red to purple at the time of titration. Now for the calcium hardness, once again I will take 25 ml of sample. Now you have to add 2 normal NaOH. Once again it acts like a buffer solution to maintain the pH. Now I will use another indicator, that is called Mur oxide, once again salt. So a pinch I have to add. Mur oxide indicator I will add. Now you will get wine red color. You will get the wine red color, right? So once again, after getting the wine red color in the conical flask, I will titrate, note down the initial reading, then do the titration. Until color becomes violet. Now the color becomes violet, right? So now you can see initial color, final color, initial color and final color, right? Once again note down the consumed, the EDTA solution, 3 trials, average I will take, then I will calculate, initially I will calculate the calcium hardness, then using total hardness minus calcium hardness you will get the magnesium hardness. That we will see in the tabular column as well as in the calculation part. Now we will see the calculation part. First the tabular column. So this is for the total hardness and permanent hardness. Final reading, initial reading, final reading minus initial reading. I will take 3 or 4 trials. V1 for the boiled and cooled water, that is for the permanent hardness. Initial reading and final reading is taken. The average of that is V2. Next, what is the calculation part? So total hardness, the value is V1. The B is equal to 1 because I have taken 1 molar, 0.01 molar EDTA. Right, 1 ml of EDTA solution is equal to 1 milligram of CaCO3. Therefore, this B is equal to 1. V1 is whatever the tabular column V1 I have got, average of the titration reading into 1000 divided by ml of sample, because I am here I have taken 25 ml of sample, that is 25. So for example, average value 2.3 I got, 2.3 into 1 into 1000 divided by 25, that much milligram per liter of CaCO3, that is the total hardness. Similarly, for the permanent hardness, only change is V2, whatever the V2 value. One thing I should note, either V1 or V2 is equal to 0, or V2 will be generally less than V2 is less than V1, because here it contains both temporary hardness as well as permanent hardness. Here we have only permanent hardness. So V2 into B, that is 1 into 1000 divided by ml of sample. Here it is 25. Next, how to find out the temporary hardness? I have the total hardness and permanent hardness. Temporary hardness is equal to total hardness minus permanent hardness. Directly I will get the value. So next I will write it down in the result sheet. Total hardness, permanent hardness and temporary hardness. Next we will see how to do the calculation for calcium and magnesium. First I will find out total hardness using that formula. Then calcium hardness is equal to V3 into B into 1000 divided by ml of sample. Some value I will get. Then total hardness in terms of CaCO3, right? The calcium hardness Ca, that is in milligram per liter, is equal to 0.4 into calcium hardness, whatever the value I have got here. So 0.4 into X value in terms of CaCO3, right? In terms of mg per liter. Right? Next, magnesium hardness is equal to total hardness of CaCO3 into calcium hardness. First value before whatever the 0.4 multiplication, whatever the value I have got, right? So total hardness minus calcium hardness. So magnesium hardness in milligram per liter is 0.24 into magnesium hardness, the value I have got here, right? So in terms of mg per liter. Finally, the values: total hardness in terms of CaCO3, calcium hardness in terms of CaCO3, calcium in terms of mg per liter, magnesium hardness in terms of CaCO3, and magnesium in terms of mg per liter. In the remarks column, you compare it with IS 10500 2013, whether it is within the permissible limit or whether it is in desirable limit or it is more than that. Thank you.